Now that the home is prepared for the blower door test and we have the blower door assembled and inserted into the frame, we are ready to begin testing. We want to be careful that we communicate to the occupant how loud the test may be and communicate any other issues that we foresee on the job. Today we're going to learn about how to zero out the blower door gauges and how to run a series of basic blower door tests. Depending on the type of blower door you are using, there are a number of different ways to zero out the equipment. It's important to zero out the gauges so that we have a baseline benchmark that we're working from. Zeroing out the gauges ensures that we're at zero pressure in the building with reference to the outside before we start the blower door test. This is an analog gauge where we have to manually adjust the pressure. This gauge here shows the house pressure with reference to the outdoors, and these two gauges both show the fan pressure as well as the CFM of air moving through the fan. I've adjusted all three of the gauges to the zero position so that when the test starts, we have an accurate reading. On this digital manometer, it has a self-zeroing feature. We want to make sure that the tubes are connected to the outdoors in order to zero the equipment out. Now that we have the blower doors set up, we want to make sure that there's nothing around the blower door fan on the inside or the outside so nothing can be sucked into the unit itself. We're also concerned about the noise of the fan itself and making sure that the occupants are aware of how loud the system is going to operate. Once we have cleared the area of around the blower door, we can turn the knob on the speed controller to start turning the fan speed up to the point where we're going to reach 50 pascals of exaggerated pressure. A pascal is a unit of pressure measurement. That is, a 50 pascal pressure measurement is equal to 20 mile-an-hour wind on all sides of the building. It's a scientific unit of measure that was established from a French mathematician centuries ago. It is the standard by which we use, the pressure standard that we use to do all testing, blower door testing. When we look at the gauge and look at the CFM measurement, or the cubic feet of air per minute measurement, we are measuring how much air is moving through the fan. And the amount of air that's moving through the fan is leaking in through cracks and holes in the building envelope. Doing the blower door test is not going to affect the indoor environment in a way that it's uncomfortable to live in, or if someone has health problems, or if there's young children in the house, it is not going to cause any problems or discomfort aside from a temperature difference because of how much air is moving through the house. The pressure difference is not significant enough that it's going to cause any problems for the occupants. If there is a power outage that happens during the blower door test, we need to start over, re-zero out the gauges, and start the fan back up to bring it back to the 50 pascals and re-administer the test. Now that we have the blower door frame inserted into the door and the fan inserted into the skirt, we also have the tubes connected from our digital gauge. This tube is connected to the outdoors because we're going to be referencing our indoor pressure to the outdoor pressure. We're going to depressurize or pressurize the building to a 50 pascal negative pressure or positive pressure. This tube here measures the actual air moving through the fan, the amount of air going through the fan during the blower door test. I have the gauge configured so that we're on the blower door. There's an actual device that it's connected to. This is set up for blower door and the ring size that we have on the fan. So I'm under the blower door and on the open fan. I've zeroed the gauges out so that we're starting at the benchmark baseline of zero pressure. Now I'm ready to start the blower door test. What I'm going to do is I'm going to turn this fan speed control on until I reach a pressurization level of 50 pascals. Once I reach the 50 Pascal mark, I'm going to look over here and see how much air is coming through the fan at that moment. You can see that I'm at really close to the 50. And there's 4,555 cubic feet of air moving through that fan at this moment, which means that's how much air is leaking from the fan and out through all of the cracks and seals in the building. If we have a problem reaching the 50 Pascal pressurization, we want to walk around the building and make sure that we've properly prepped the house. There may be an open window, there may be an open door, or a door that didn't latch correctly and came open during the test. There may be a damper on a fireplace or a dryer vent that is open, and we need to make sure that that gets closed. Once we've done that, we can come back to the blower door, restart the test, and make sure that we get to the 50 pascals. We're always trying to get to the 50 Pascal pressurization or depressurization. Every blower door test that's done is done to that level. That is the sort of the standard in the industry of what level each house gets pressurized or depressurized tested to. If we still can't get to the pressurization of 50, we have to look at removing another ring to allow more air to move through the fan to reach that pressure difference. If we can't reach the 50 pascals of pressure through the blower door or on the gauges, we know that there's either a large leak in the building or we did not prep the building properly, or the building is leaky enough that we're not going to reach the 50 pascals of pressure difference. If we cannot reach it, there is a chart that's a can't reach 50 factor where we take whatever the house pressure is, read on the manometer, and multiply it by a factor of 1.1 or 1.2. For example, if we're at a 30 Pascal pressure difference between the inside and outside, we will multiply the CFM that's on our gauge times 1.4 to get what it would equal at 50 pascals. One of the unique features of the digital manometer, which measures the pressure, is that it has a timing function that you can take a measurement every 1 second or every 5 seconds or every 10 seconds. And if we have some adverse conditions outside, if it's windy, we may want to do a time average and extend that time out to longer periods so that it balances out any dips and upflows in the wind so that we can get the most accurate measurement to get to that 50 pascals with reference to the outdoor pressure. All of this equipment is very expensive and very high quality and is fragile. The digital manometer is the most fragile piece of equipment in its measurement of pressure and all of the electronics that are involved. So being very careful to make sure that that is never dropped, that it's always carried within its case. It actually comes off of this mounting bracket and can get inserted into a soft case. The tubes over time, after being inserted and taken off of the pegs, may become stretched out or frayed, and it's okay to clip off the end of the tube at that time to give you a fresh, tight seal. The fan is also very fragile. It has pressure measuring devices on it and the motor itself, so being very careful to make sure that that gets inserted into its case after the completion and before blower door tests, that it's always carried in a soft case that protects the fan. The fan itself does not need to be oiled. It is a closed, calibrated, sealed unit. But making sure that there's not dirt or dust that gets introduced into the motor itself is important. The skirt or the tent that goes around the frame of the blower door can also become frayed or torn if it's not cared for properly. Being careful, again, to make sure that the least amount of wear and tear occurs on the tent. The frame is fairly robust, however, it can be damaged if it's dropped, can be bent if it runs into something, so it's always important to make sure that we care for all pieces of our equipment. Storing them securely in the cases that they come in and transporting them carefully. If we encounter extremely windy conditions in setting up the blower door, it's very important to get the tube in a location that is least affected by the wind. If we have a bucket or something else to cover the tube so that it's a stable pressure, that will give us the most accurate reading of outdoor pressure when we're administering the blower door test. Before we had blower doors, we had no way of measuring the amount of air that leaks in and out of a building. With this contraption, we are able to specifically test how much air is leaking through cracks and openings in the building. Through the use of this blower door, we can air seal and tighten buildings and make them more energy efficient and comfortable. Once you understand how to use the gauges and the blower door system, we can move on to further levels of testing. And that's the basics of how to run a blower door.